We are going to do a test. Okay?
Yes.
I get and the test is going to be online, and I don't know. And your parents, they need this report. I'm going to send it to them. They have already designed a system where I can send the report direct to them. Okay?
Okay.
So if you want to disappoint your parents just by keeping quiet and you're not concentrating, remember we are making some payment. Okay? So you need to concentrate to maximum. Okay?
Yes.
Yes. So
Yes,
don't let your parents down, please. Don't let your parents down, please. They're doing everything for you. Okay? Are you getting me? Huh?
Yes, teacher.
Yes.
Yes, teacher.
So laziness should not be part of our life. Even I don't want any of you to get even closer to it. So if I hear that someone is lazy, yet they are supporting you in all ways, they are buying for you data, they've already paid for you everything. And remember, you're at home. I have no full control over you now. It's not like those days when you are in school where I can go and take you from class. I ask you what is the problem. So these days, the only way you can talk to me is either through WhatsApp, or you call me direct, or when we are having lesson like this, that's when we can interact and then we discuss more. But when we have time for doing anything, let's do it to our best. Okay? Let's do it to our best with when you must be interested in everything you do in life. Are you together?
Yes.
Who is this one? Who is this one calling himself Techno? Who is this one? Techno F1. Who is that one? Techno F1. Who is that one?
Lynette.
Is Lynette?
Yes, teacher.
Today you are calling yourself Techno F1.
Chado.
You have started hiding your face from me, eh?
Teacher.
Innocent. Innocent.
Yes, teacher.
Innocent, I've not yet seen your work. When are you submitting?
Teacher, I'm going to submit.
I'm going to call your mom. You be there. I'm going to call your mom. You want me to call your mom?
No?
Yes. Please. Be self-driven. Be self-driven, okay?
Yes, teacher.
Yes. Now, okay.
Yes.
It's like you want to lead us in prayers. It's okay. You start and we start our lesson officially. Lead us in short prayers and we start our lesson.
In the name of the Father, Son, and the Holy Spirit.
Amen.
Oh Lord, we thank you for keeping us alive. We thank you for guiding us and for guiding our teachers. Lord, we ask of you to provide all the basic needs we need, most especially in the lessons, and that we should not become lazy and be able to finish all our work and submit. I pray this in Jesus' name. Amen.
Amen. In the name of the Father, the Son, and the Holy Spirit. All right. Thank you, Narukenge. Patricia. Yes, Patricia?
Yes, teacher.
Are we together?
Yes.
Very good. Patricia, where did we stop? Patricia, where did we stop? Yes?
On gun, is it gun and bullet?
Gun and bullet.
Yes. No. Revision.
Yes, we did some
In the revision.
And we did some few questions. We did from number 1 prep on section A. We did prep from question 1 to question 5. Not?
Yes.
Yes. Now, after finishing this topic, our test will come from that question. We have them down there, but I don't know which one I will say. Okay? So the test we are going to do is going to come from those questions you are seeing there on our assessment. Okay? So I will put on a notice board when you are going to do the test, but after finishing this topic, after finishing this subtopic we have started. Are you together? Yes?
Yes.
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 So today we are going to look at today, I believe you are able to see what's on my screen, right?
Yes, teacher.
Yes, we are going to look at Newton's laws of motion. Okay, that's our heading for today. Someone may ask, we know that Newton is the SI unit we use for force, but Newton is the name of a person. Is the name of a person, Sir Isaac Newton. So he did so many discoveries in physics. But most importantly, what made him so famous in science is because of the Newton's law of motion. And remember, we are looking at laws. Laws that are different from principles. Laws and principles that are not the same. Laws, these are the fundamentals, which we cannot refute them, we cannot change them. So those are natural phenomena. Whether you want it or not, we experience them. Okay? So was Newton, he just took the baton from someone. He took it from a man called Galilei. Galilei started the investigation, but it was so unfortunate. He died before finishing his investigation or before finishing his experiment. Then from there, Newton took it from him. Then he came out with the 3 laws, which we call the Newton laws of motion. And these laws, they affect us in everyday aspect of life. That's why we said physics. Physics is the fundamental of life because physics is natural. Physics is what? Natural. Physics is natural. That's why sometimes when you go to some other books, they say it is a natural science, which relates find the relation between energy and the states of matter. So because matters are real, they are not virtual. But it's through from this what we call classical physics. When Newton came out with what we call classical physics. Classical physics, that's when now the whole aspect we started understanding the nature or the natural phenomena in life is because what Isaac Newton started. But they came out with very fundamental laws, which talk about motion. Okay, we have seen at that time the type of inertia. For Newton, he was trying to ask himself, why is it that an apple was able to fall down? Those are the questions he was asking himself. Sometimes when you want to move forward in life, you need to know what you want. You need to be in position to imagine. Imagination is the key to success in sciences. So you have to be imagining. So Newton was trying to find out why is that an apple or a purple is able to fall, not again going up. Why is that? Every object that goes up must come down. So those are the things Isaac was trying to find out. Then when it comes to motion, it was specific on linear motion. For him, he was looking at only linear motion. And we say linear means motion in a straight line. He also went ahead to look at circular motion, projectile motion. He did some investigation there, but the most important one is the Newton law of motion that made him become so famous. Okay, are you together? Are we together, members?
Yes, teacher.
Yes.
Yes, teacher.
Yes. So Isaac did so many things. The question we may ask, why is it that when you are running, before an athlete, take for example, an athlete who is running, maybe you want to take high jump or a triple jump? Why is that you have first to run before you jump? Have you ever tried to ask yourself that question? Why is that you have first to run before you jump? Can you jump when you are just standing? Can you jump to the greater height? Can you jump to the before running? You have first to run, not so. Then you jump so that you can jump to a greater height.
Yes.
Why is it that? Why is that? Isaac, we are going to find reason for that looking at Newton's law of motion. Then another question we may also ask: when you are in a taxi, take for example, when they are bringing in the passengers, you sit down, right? Then immediately when they start driving, do you jack forward or you jack backward? Do you jack forward or backward?
Forward.
You jack forward.
No. Yeah.
Do you jack forward?
No.
Jacking means like to move backward, to move backward or forward. To jack is to either move forward or do you move forward or backward? When a taxi is just starting moving, do you move forward or backward?
Backwards.
You move backward or you jack? You jack what? You jack what?
Backward.
Backward. Why do you jack backward? Why do you jack backward? Then also another phenomenon is after some time when the taxi is now moving, when the vehicle is in motion, okay? After setting the vehicle in motion, again when they apply a brake, you find that you jack forward, right?
Yes.
You jack forward. Why do you do that? That is also what is it? We are going to explain that one also in Newton's laws of motion. Right together. And that one is best explained in the term we use for that one is what we call inertia. The term is what? Inertia. And I remember that time when we were looking at, we have already defined inertia. Who can help us to define inertia? What is inertia? What is inertia? Yes?
Inertia.
Yes.
Inertia. Okay, never mind.
Is that?
Tendency
Yes.
of a body.
Is a tendency of a what?
Of a body.
Yes.
To be at rest.
To be at rest.
Or to keep moving.
Or to keep moving in a straight
line.
In a straight line. Okay. So that tendency, the inability. Okay. Sometimes if you don't want to use the word tendency, you can use the term inability. Okay. Inability. The inability of a body to start moving, or to remain at rest, or to continue moving in a straight line, is what we call inertia. Are you together? Another time we have discussed them, we said we have 3 types of inertia. Who can remind us? We have 3 types of inertia. What are they? What are the 3 types of inertia? Yes, please.
Inertia of motion.
Inertia of motion, yes. Yes, Patricia?
Inertia.
Yes, Patricia. Yes, thank you, Beatrice.
Inertia of direction.
We have inertia of direction. Then lastly?
Inertia of rest.
Inertia of?
Rest.
Inertia of rest. Good. And we gave very many examples of that, okay? Now, another question you may also ask. In real life. Why is that when you kick a ball, when you are kicking a ball, there's a way you react. No, so how do you react? How do you react when you are kicking a ball? You feel some pain, also, like when you kick a stone. When you kick a stone, what the level of the pain you experience depends on the force of applied, right?
Yes.
When you use a greater force, you feel much pain. But when you use less force, you feel also less pain, right?
Yes.
That one is also was explained by Newton, okay? In what we call Newton law of motion. We are also going to look at all of that. So now, we can also go ahead. We can also go ahead to look at different form of reaction, okay? Like the other time when we were looking at momentum, we said for every force that's applied, there's always a reaction. There's always a reaction. And we feel there's that reaction that we normally experience, okay? For every force that is applied. And we have seen the effect of force, the effect of force or the impact of force, and they are 5 in numbers. Are you seeing what is on the notes? For the notes. Okay?
Yes.
A force can make a stationary body to move. That's one effect. When you apply a force on a body, that force can make a body to move. When it's at rest, it can make it to move. It can also increase the speed of a moving object. Is it true, members? It can also increase the speed of a moving object. That one is also another impact of or effect of a force. Or it can also use force to slow down or to decrease the speed of motion of a body. Okay? How do you reduce the speed of a moving object? By applying a force. Which force is that? Which force is responsible for that? Frictional force, right? That force is what? Frictional? The frictional force. Then, when you apply a force on the body, it can also make the body to change its direction. It can also make a body to change its what? Direction of motion. Or it can also deform a body or can change its shape. Are you together? Are you together, students?
Yes.
Yes. So those are the 5 effects of forces when we apply them, or of a force when we apply on an object or on a body. Okay? Now, like I've said, I remember talking about Galileo, not so. We are saying that the relationship between force and motion was stated by Galileo, an Italian scientist. And he died before he could finish what? He could complete his investigation. His work were continued and completed by the English scientist called Sir Isaac Newton. Are you together? Are you together? Yes. So the work, Isaac did not start the work. It was started by Galileo, okay? An Italian scientist who started investigating the effect of force and on motion, but he did not finish. He died. So unfortunately, he died. Then the work was taken over by Sir Isaac Newton. And Sir Isaac Newton carried out a series of experiments. He did very many experiments, and he came out with very many laws. And those laws are being summarized into 3. Okay? The laws are being summarized into 3. Now, what we call the Newton law of motion. Are you together, students?
Yes.
Are we together on that? So that's a brief background about how the laws came about. Are you together?
Yes.
Yes. Now let's write down the first Newton first law of motion. 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 We are saying if it's a law, the opening statement must be it states that. The opening statement must be it states that. It states that. Then you continue with the statement. So the Newton's first law of motion states that everybody or every object continues in its state of rest. Continue in its state of rest of uniform motion, or of uniform motion in a straight line, or of uniform motion in a straight line, unless acted upon or compelled by an external force. Right together? It says that everybody continues in its state of rest or of uniform motion in a straight line unless acted upon by an external force. What does that one mean? Now, right now you are seated. Not so? Right now you are what?
Yes.
You are seated. For you to change that state of motion, of that state of rest of yours, there must be a force that must be applied. You must apply certain force for you to move, right? Or to change that state of motion. I think that, members.
Yes, teacher.
Yes. Your calculator, this calculator is, my phone is here. Okay? This phone, according to Newton, Newton is saying this phone must continue remaining at rest unless if I applied a force on it. So which means if I move it away, which means I've already applied a force on it. Otherwise, this body must continue remaining there. Right? Are you together? The object must, if you are moving, according also to Newton, if you are moving, you must continue moving. You must never stop. Are you together? You must never what? Never stop. Unless if you applied a force for you to stop. Are you together, members?
Yes, teacher.
Yes. In a nutshell, who can summarize? Who can just state first Newton's law of motion? Just state it and we could proceed. Who can state it for us and we proceed? Because we want to move together. Who can state it for us and we proceed? It says that, Please stop writing on my notes, please. Stop writing on my one. Who can state for us the Newton's first law of motion?
Newton's first law of motion states that a body of rest.
Everybody, yes.
That everybody continues motion.
Unless acted upon by an external force. Good. That is it. Remember that. So when they ask you state Newton's first law of motion, that's the answer I want you to write. Okay? Right together. Yes. Moving forward. Now we want to go and experience them in real life. Common experiences that have shown that objects at rest do not begin to move on their own unless they are being acted upon by an external force. Then as a result of this, the following are cited as an example of Newton's law of motion. Members?
Yes, teacher.
Yes, teacher.
The first Newton's law of motion, we can also refer to as a law of inertia. Okay? The first Newton's law of motion can also be referred to as law of inertia. Right together.
Yes.
So when you come across a question which says state the law of inertia, just remember they are referring to the first Newton's law of motion. Okay? Yes. So we are saying a body at rest. When a pile of coin is placed on a table, the one that at the bottom can be removed by applying a certain force to it without disturbing one on the top. One on the top. We have all experienced that. Like when you're removing, like for example, on your dining table, when you're having a dining table, okay? Not just any table. When you put a piece of cloth, and then you put maybe a cup Okay, a cap on top. And when you are moving the cloth, you find that it's only the cloth moving, but you find that it's as if the cap is stationary. As if the cap is what? Stationary. Why? Why? It's because the force you are applying, you are not applying it on the what? On the cap. You are applying it on the what? On the cloth. So that's why it's only, you see, as if it's only the cloth moving. The cap will remain at rest because there is no force applied on it. Are you together?
Yes, teacher.
Yes. So the explanation, we are saying the force applied only acts on that particular coin at the bottom, since the rest are not being acted upon by the force. Then they remain undisturbed. Then they remain. Then they remain undisturbed. Right together.
Yes.
Yes. So that in the notes, I'm using a coin. I'm using a coin. Another example you can also use. You can use a tablecloth, and maybe a cup. Okay. You can use a tablecloth and then a what? A cup. Then another one is B. Motion, a body on motion, a body on motion. It's like when you are running. Say for example, you are running. You are taking your evening walk. You are jogging in the evening. You find that when you are jogging, you can't stop suddenly. Not so. You can't stop suddenly. When you want to stop, you are first move a certain point before the what? The end point. You get?
Yes.
Yes, that one is trying to tell you that because you already set yourself in motion, for you to stop, there must be a force that must be applied on you for you to stop. Otherwise, you cannot stop unless there is a force applied. That's what Newton is trying to explain. So they are saying a person riding a bicycle along a level road does not come to rest immediately. Right together. It does not come to rest what? Immediately. When you stop what? When you stop pedaling. When you stop pedaling, it doesn't come to stop at rest immediately. The bicycle will continue to move forward for some what? For some time, but eventually come to a rest. Are you together on that?
Yes.
Yes. That one also, another example we can give on that. Another example we can also give on that can also be. I remember giving when I was starting the lesson. When I was starting the lesson, I talk about the athlete, not so? A high jumper. If you want to jump to a greater height, you must first run a given distance, then you jump, right? All those are explaining the concept of a body on motion. What explanation do we give for this? What explanation do we give for this? We are saying a bus will continue to move because of inertia. Remember, a bus will continue to move because of
Inertia.
Because of inertia. After some time, as a result of the retarding action, and that retarding action can be frictional force, can be air resistance. Are you together?
Yes.
Yes. So they may ask you, give two forces that is responsible for making a body to stop moving in a straight line. One of them is the air resistance, okay? Then another one is the frictional force. Those are the two forces. Those are the two forces responsible for making a body to come to rest. Yes. So a car is able to come to rest is because of the frictional force between the tire and the road surface, right? An object thrown up in space is able to come back because of air resistance. On the ground, on Earth's surface is frictional force. In space is air resistance. Are you together, members?
Yes.
Yes. We are saying this external forces opposes the motion, and the surface eventually come to rest. Okay. Yes. Then another aspect we must also look at, apart from apart from a person riding a bicycle, collision of two vehicles. When two vehicles collide, when two vehicles collide, we are saying collision of two vehicles, or when brakes are applied suddenly, when brakes are applied suddenly to a car moving in a high speed. Members, we have all experienced this. When you are riding a bicycle, take for example, you are pedaling at the high speed, and suddenly you apply a brake. What will happen to you? What will happen to you? You are pedaling, you are cycling at a very high speed, terrible speed, and then suddenly you apply a brake. What will happen? What will happen to you, the cyclist? You may fall. You may fall. You may fall, right?
You get injured.
Yes.
You get injured. That's the reaction you are getting. That's the what? The reaction you are getting, okay?
Okay.
Yes. So we are saying in the above incidents, the passengers do not fasten their what? Safety belts and are often injured when they jerk forward and they hit the what? The window screen. Now you see, scientists, because now when a vehicle is moving in a terrible speed, even you, the passenger, you'll be moving at the same speed with as if you like the vehicle, at the same speed like the car. Are you together? When you're in motion, the car is in motion, even you will be also in what? In motion. So when you apply the brake suddenly, the car will stop moving, but for you will continue moving. Are you together? For you will continue what? For you will continue. You will continue moving. That's why you end up hitting. You end up jacking forward. Are you together? You end up jacking what?
Yes.
You end up jacking forward and you hit the what? The screen, the windscreen. That is for the case of a car. Are you together on that?
Yes.
Another example we can also give is for a bullet fired at an angle. A bullet fired at an angle. Okay?
Yes.
Yes. All those are, we can give as many as possible. We can give as many as what? Possible. But the most important thing now, you know the concept, right? You have understood the concept, right?
Yes.
Yes.
Very good. Now you can see that experiment. I've seen that experiment there. Let's go to that experiment. An experiment to demonstrate Newton first
Law
law.
of motion.
Yes. Can you draw that? I think you can go through that in your free time. But all those are the things I was explaining. That is a simple experiment. I've now put it in the experiment. Who can demonstrate for us that? Who can get for us that? Who can do it for us? Nalokenge.
Yes.
You can demonstrate that one for us, right?
Yes.
You get a glass of water. Get a glass of water.
Okay, give me a minute.
Nalokenge, are you doing it? Let's all do it. Let's all do it. Can you get a glass of water? Get a glass of water.
Yes.
You have got that, right? Then can you get some piece of paper? Or a cardboard, if you have a cardboard.
I've got teacher.
Are you following me?
Yes.
Then just get a coin. Do you have a coin there? Just get a coin.
I've got.
Just a coin. If you cannot get a coin, then get a nail. Just get a piece of nail.
I've got teacher.
You set it. Are you seeing my setup?
Yes.
Before this one, I'm meaning this one. Are you seeing where the cursor is?
Yes.
Now you try to pull the paper. You pull it gently. Don't use a lot of force. Gently. Eh?
Yes.
What have you observed? What have you observed?
The paper is the only one moving. The coin is at rest.
The coin is at rest. So you find that the coin will fall in the what? Into the glass, not so?
Yes.
That one is explaining. What is it explaining now? What does it explain? Who can explain that? Why is it behaving like that?
Friction.
Miriam. Olympia. Yes, Olympia. Yes, Beatrice.
Due to friction force. Yes, teacher.
Can you explain that? You explain that one now. Explain that.
It's due to friction force.
It's due to
Friction force.
no good. The frictional force between the coin and the cardboard makes them to move together, right? Make them move together. But when the experiment is repeated with time, okay, you find that it's only the what? The paper, the cardboard which is moving. The coin will remain at rest. The coin remain at what? At rest. Okay? Are you together?
Yes, teacher.
Yes. Yes, Alexandra. Yes, Alexandra. Alexandra, I'm seeing your hands is up, please. Can you talk? Yes?
Teacher.
Yes, Alexandra? Alexandra, was it a mistake? I saw your hands up.
The force is being applied on the paper.
Yes?
And so the coin falls into the...
Because the force is not applied on the coin. The force is only applied on the piece of paper, right? So it's only the paper which is going to move. The coin will remain at rest. Are you together? So that is briefly the experiment. We can look for that. And that one is explained now, the whole aspect of the Newton's first law of motion. They explain Newton's first law of motion. Are you together, members? So we shall take a break. We shall take a break. Then after 2 minutes, we join back and then we continue. So far, is there any question before we go for the break? Any question? Is there any question before we go for a break?